Hello, my name is Rod Kowicki. I'm doing this video about the universe based on a new theory that I've developed. It's a whole new theory. It takes essence to everything that's written about modern physics, the speed of light, E equals mc squared, relativity, quantum mechanics, quantum physics, even string theory. Vaguely speaking, the quantum physics theory is an explanation of the universe, preferably how it came to about, and and a missing part in the Big Bang. What is the Big Bang? The beginning of all things in the evolution of our universe. This big universe. What's so mind-bending is how can anybody's imagination completely fill all the information that is in the universe. The top winning prize in 1905 was relativity. The theory of relativity, special relativity, and general relativity. General relativity is this mathematics behind special relativity, which is an imaginary story about a ship that can travel at the speed of light. He took that ship. I want you to understand this. He took a spaceship and says, this thing can travel just as fast as the universe, or just as fast as gravity allows it. In essence, he took Earth gravity, 9.8 meters a second, that energy, same energy, that same mathematical conclusion relative to the speed of light, and took it into space and says it's the same. Quantum physics has restudied it, reread all these ideas in general relativity, and its conclusion is space is empty, but it has chunks of matter in it, which is mass. Now, before a material object becomes mass, which means energy, it has to be transformed. Mass, energy, a dormant state of a mass that collapsed on itself. As such, broken down smaller pieces, created a field and became energetic with the other parts of that field, the other elements, the other atoms, and everything in that matter. That's what the Big Bang did. But preferably with the Big Bang, the missing part about the Big Bang, it doesn't explain gravity. Relativity claims a flat universe, static. Everything kind of like stays the same. A flat universe, whether it's square or it's round like a pizza, if it spins, because planets and galaxies spin, it replicates a hole at the center, which is called a vortex. And all these things, we talk about vortex in the universe, and the spin of atoms as well as galaxies all come from relativity and that theory. Everything's on a flat surface. Edwin Hubble in 19 1943, 42, was looking out a telescope and discovered that the galaxies were traveling away from each other. Something was happening there. The universe, not the mad observable universe, the material universe, but space was expanding. Space, empty space, there was getting more of it. It was getting bigger, which put a physical objective to space. What is space? When we go back to the Big Bang, Edwin Hubble did a very good, he goes all the way back to the void. In other words, a bubble was formed. We drop a nuclear bomb on Earth and it kills everything in sight, but it leaves a big damn hole. A big hole. Because that surface is blocking. It's blocking the 360-degree explosion of that nuclear bomb. Take that same bomb, take it out in space. Reluctantly, it explodes. It's 360 degrees. Everything, scattered matter, goes in all directions. Three-dimensional, 3D space. Space is 3D. The physical image of space and matter is 3D. 4D comes in when we examine the first action of that matter, which is velocity. Besides being different elements in the different elements. But anyways, you explode that nuclear bomb in space. It's 360 degrees in a three-dimensional space. Time starts with time equals 0 when that explosion started. That's time. Okay. Space, empty space, has some kind of mass. It's a carrier of energy. So it's not energy. Energy can go through it. Energy can be measured on Earth in the atmosphere as far as being going place to place. Objects. Your remote control. Click a button here and it goes off over there because of the frequencies. In space, it's different. It acts the same way, but it's three-dimensional. Space is not made up of energy or any type of energy that we know of. It's an element. It acts as a carrier force, but things can move on it. Planets, stars orbit in it. They rotate. They stay steady state. But when the Big Bang happened, think of this as everything exploding to a point to where everything broke down to its smallest parts, mass, of the elements, created a field, and then shrunk back. Space as a carrier force allows what's it called? Flexibility. Boom, and things are allowed to move, and it's not held by anything. It's not held by the speed of light, as relativity says. An explosion occurs, or the nuclear explosion, and everything seems to go in a empty space that allows it to increase its vulnerability, and break down and shrink back to its original form. During that time, the hole that I was talking about on Earth that's formed, like 150 square mile radius of nothing but desolate death, radiation killing everything. In space, all that is in mobility because of the force of the explosion. As much mass as there was relative to the explosion that occurred, that same amount of mass shrunk back to its smallest element and reformed in the universe. At the center of that massive explosion, there was nothing left but a round hole or void of empty space. That same space became concentrated. It became concentrated. It reformed as well, but not all the space that the universe is made of. I mean, look at the mass compared to the space in the universe. I mean, it's spread out all over. We got a big darn universe, right? So it's only a small part. What, 3% of whatever? Let's say 30% is mass, and the rest is space. Space, nothingness, and distance between these galaxies. This void in the center became concentrated the same way as the energy around it became concentrated. But the mass around it, the matter around it, like the galaxies, they broken down, reformed into a mass energy matter. So now they're stuck in a gravitational environment of each of them, whatever that was made up, star, planet, galaxy, different planets, whatever, gases. All these things are individual elements. Space is not an element, but space also became concentrated. And that's what all the galaxies cling to. But the void, this balloon Edwin Hubble talks about, or this bubble that Stephen Hawking talks about, or this Eunice that Mikio Kaku talks about in string theory, that looks like it's like a thumbprint virus. If you ever saw his idea of what it was. And preferably, it's probably a real good idea about what it looks. I would say it's a type of virus, yeah. It has energy in it, it has a bunch of stuff in it, But that void became concentrated. What's happening is that void is rechanging. It was the center mass of the Big Bang, the nuclear explosion I talked about, the center mass. Reluctantly, since it's flexible, it has mobility. Having mobility, it's growing. So and matter is not growing because it's mass energy. Space is only space energy, but it's not made up of the same energy type. It's probably just the opposite. When you talk about matter, antimatter is matter that is negative, is positive in a positive field, which doesn't attract each other, pushes each other away. But it's called antimatter. So reluctantly, we have a space that's expanding, it's getting bigger. It's the same density of the explosion in the Big Bang, that the space in the center of that explosion, when it shrunk, also shrunk. because it was trapped in the center of the explosion. You know, kind of like a black hole that explodes. This is my theory on black holes, that they are, since they're in the middle of each of those galaxies and stuff, that they are a portal to that same galaxy. An explosion occurred, and the black hole is the aftermath of the explosion, but it's still sucking stuff up. It's trying to suck up back what it put out there, which changed into matter. Reluctantly, just after the Big Bang, the young universe, as you might say, that the galaxies formed were in a complete different form. They were young, they were highly energetic, had a lot of energy there, and reformed. And then when the Big Bang happened, they exploded again later, creating the different galaxies in the different areas. Since they were similar, the different galaxies that were created, they repelled each other. They weren't attracted. They're only attracted to a point to where how small one is and how larger one, and the difference in between of those two energies. Kind of like with Isaac Newton. I talk about this in my books. But anyways, what I'm talking about in my theory is theoretical. That now, Edwin Hubble talks about this void in the center. I don't know whether he got that idea from Albert Einstein. It's the Big Bang. But preferably that it was a Big Bang, and from a singularity. It was a singularity explosion. In my work, working on a couple more books, I have some mathematical formulas, how fast an object can travel in space relative to the gravity expansion of the universe, which is relative to velocity, as Albert Einstein reflected. But see, energy waves, alpha, omega have alpha waves and omega waves that travel back. Alpha waves travel forward, omega waves travel backward in a gravitational field. You take that gravitational field, there's no action in the omega waves to go back. There's no negative energy to positive or negative energy that enforces the change that alpha and omega waves possess or have, their process. So relative to the speed of light and the velocity, the velocity is actually twice as fast in space where there's no controlled environment. It's elusive, Things, matter, and space travel the same way because they're not interrupted by anything else. So unless they get interrupted by the presence of some other object, they don't change. And that's how the universe formed, into this type of atmosphere. but just think about it. The universe, the age of the universe is a flat universe from center to like a pizza, to the outer edge, spinning. A three-dimensional changes things. It's like a basketball spinning, and it's three-dimensional. Relativity in the flat universe is 1 and 2. Dimensional. But in a three-dimensional, without time, the universe is round like a basketball. It changes everything. It changes the age of the universe. It changes the length of the universe. The age, the length. How old the universe is. There's a lot that changes in there, and with this information, a new theory is formed. We take all our speculation, but they're speculated on E equals mc squared that R is blocked by a certain velocity. It's constant. It doesn't change. So it doesn't change. That means when you turn off the light bulb, it's dark. You turn on, it's the brightest it can get is at the speed of light, bright as hell. I don't know, but that's one click, two click. It's on or off, And if it's on, and it's a barrier. You can't pass through it. But you take a flat universe, there's 1 and 2, and you make it into three-dimensional. That changes everything. So then I have myself with the theoretical idea, the mathematics that form behind it, the numbers. What comes out is the density of this expanding universe is telling me that there's gravity is not cut off at the speed of light; it's faster. And using that formula, it tells me how fast it is. Now, 42 miles a second, as miles per second, space is filling in between the galaxies. That's not a lot. But you take the whole universe and you use that same formula, you get a mathematical formula. A new mathematical formula. Anyways, that's what I've done. This is somewhat the last part. I think I did do videos with that formula. I think I did show it up. But anyways, the universe and space, as well as its theory, and the idea that we can conceive everything in the universe. We learn from other people, other scientists. From 1 to 2 to 3, the sun, the stars, the moon. The background radiation, and everybody's through the years have taken all this into consideration. And we come to an age where we're pretty convinced this is how the universe is. Now, Edwin Hubble's theory acts as a three-dimensional universe, and the expansion theory changes the idea of what Einstein did, but yet they still use Einstein's theory. They should write something called "The Truth About It Is." But now I'm putting some in. I'm able to predict the beginning and the changes that are going to occur in the future relative to the universe. Now, there's been about 10 different ideas about what holds in the future of the universe, the reasons behind the theories, and you'll find those in some of the literature in advanced physics. anyways, keep an open mind. My videos ain't that good. You know, I may be, no, I'm not gonna say that. They're not that good. You know, because I was at that age when the young people were grasping up this new idea about electronics, computers, the way to draw, you know, graphic arts and all this. And I tried to get in, and it vaguely worked. It's probably a pretty good video, but I know I could make other better videos. Anyways, my name is Rod Kowicki. This is a quantum physics